So what is a precipitate and what is a precipitation reaction? This is chapter 4.2. So precipitate is an insoluble solid formed by reaction in solution. So in this reaction, I show right here on the screen, I guess, you see a lead nitrate, a potassium iodide reacting to form a solid, very important solid, lead iodide and potassium nitrates. So the reason why this is special is that solubility will come to be very important in AP chemistry as we move into the course. So something is insoluble if it does not disassociate or it does not become a liquid or it doesn't fully, you know how you see like sugar in water, it's just gone, you don't see little particles. If that doesn't happen at room temperature water, well specifically 273 degrees Kelvin, then we consider it insoluble. So lead iodide is an example of that. So unfortunately, there aren't any specific rules on like if this is certainly like soluble. Like there's no given rules that you'll see all the time. Like we know that some compounds will always be soluble, and we know that some will always be insoluble. But there's no element by element guide that will show you like this one will always be insoluble no matter what. Like this specific element bonded with any other element will always be insoluble. Unfortunately, that doesn't exist. They're kind of just trends. So here's a chart that I got directly from the textbook. So this is just showing the most common soluble ionic compounds and the most common insoluble ionic compounds. So except for nitrate and acetate, none of these have like a lack of exceptions. So that's what I was saying before. Unfortunately, there's no like exact rules, but there are trends that we can see, like these sulfur compounds and these carbonate compounds. We see that most of the time they are not soluble generally. So I find that in chemistry, it's much more important to memorize these rather than the insoluble ones, as they will be showing up the most. Like nitrates, I know for sure. When you're going on those AP chemistry tests with heart, you'll see for sure that nitrates, you know that immediately anything that's going to be there are going to be soluble, and especially on those first couple tests, that is critical. Same with acetate, although I don't see that as much. Chlorine, bromine, iodine, I know that those are going to be on the test because I saw them. So yeah, make sure to keep that in mind. That is super important. Okay, so the last thing that was in chapter 4.2 that we should really discuss is the idea of a complete ionic equation and a net ionic equation, and a molecular equation as well. So this equation that I'm showing right here is a molecular equation. That means that everything that we use, like for example these nitrates, these potassium iodides, everything's in here, right? And they're all in their normal non-dissociated form. So the idea of an ionic equation is to indicate whether the dissolved substances are present predominantly as ions or as molecules. So, for example, all of these are going to be ions. I might as well not write them out, but just example, for the reactants, you would write it out as this: Pb2 plus 2NO3 minus plus 2K plus 2I minus. Like it'll just go on and on and on with all these ions. And although that is useful, and we call this a complete ionic equation, by the way, although this is useful, it's not very efficient, and we don't like to use it that much. So therefore, we are going to be cutting out things that are known as spectator ions. So let me just complete this equation really quickly. So, as we can see in this little complete ionic equation, that the lead and the iodine ions are the only ones that are going to be undergoing a complete reaction, where they're going to be going from a different state, or they're going to be changing their molecular formula, stuff like that. Therefore, we consider everything else besides the lead and iodide ions as spectator ions. Spectator ions are basically things that play no direct role in the reaction. Therefore, from one side to the other, from reactants to products, they're the exact same, or they don't change in a significant way. So, for example, the potassium ions, not useful to us, and these nitrate ions, not useful to us. Therefore, our net ionic equation, which is an ionic equation that includes no spectator ions. So, our net ionic equation is going to be lead plus iodide becomes PbI2. And that's your net ionic equation. And that's all.